Professor Hall will accept a few questions, if any. Υπάρχουν ερωτήσεις? Θέσεις? Παρακαλώ, ο κύριος Βέσης.
Okay, I enjoyed your talk, but I would like to ask you, you always take for granted that the computer will be continue developing in such a way they can handle this huge amount of data. If there is at a limit, what about, let's say, the logic of that to make the whole thing such efficient to be handled by, let's say, limited computers?
That is an extremely good web science question, and I suggest you set it as a project for one of the students in the... I can't give you an exact answer. I mean, as far as we know at the moment, there is no limit. And the developments in cloud computing are going to take us to the next stage in terms of the amount of data and what we can do with it. Whether there is actually a physical limit, yes, and I think it's the same sort of discussions we have about silicon chips, isn't it? I would like a mathematician who's better than me to answer that question, but I'm not going to put anyone on the spot here. I think it's a really good question. I think what you've done is sum up why we need web science, because in order to answer that question, you have to understand much more than just how, you know, the technology of the web in order to really answer that question. So I'm not going to try and answer it, but it's a really good one. Yes.
Another point. You have just spoken about this block sphere. What can we learn from that? For example, if we have a matter, let's say, and a gas, a solid state, if we have, let's say, the equation of states or some parameters of that, we can learn some other properties of that. In this case, I guess that the property that gets the information, or in other words, the entropy. How can we get some, let's say, macroscopical parameters that can characterize the block sphere?
That, again, is the sort of thing we're looking to do in web science. I'm going to duck your question, I'm not the right person to answer that. But for sure it is a question we need to look at what's happened and try and generalize into the future as to what might happen you know, in the world of linked data. What are people, if there's all the data in the world is out there, what are people going to want to do with it? The blogosphere was very much this idea that people would want to write web diaries on the web, and then the technology allowed them to link it all up. Basically, the backtracking allowed them to link to other people's blogs, and you've got this interconnectedness of blogs, and that enabled the whole thing to take off. And so it is a mix of human behaviour and what the technology is allowing people to do, and the software applications that are written when people see that, weblogs, blogs, people want to do that, let's write let's write some software that people can download to create blogs. Anticipating what might happen in the future by learning from those stories in the past is very important. There is a debate about whether we can develop theories or not, and that's one of the controversial things. We like to think we can, but they may not be theory. I mean, I think we need new types of theories because we can't do the experiments that we're used to being able to do. As I said, it changes faster than we can observe it. So if we take a snapshot, it's changed by the time you take the next one. And so we need to do longitudinal studies, we need to do quantitative, qualitative analysis, all the things that computer scientists are not used to doing. We need to learn how to do those.
Δύσκολες ερωτήσεις. Ο κύριος Λούκος. Δυνατά, κύριε Λούκο.
Do you think the web will scale forever, the number of users? Because, for example, Twitter, as far as I know, recently it doesn't scale that much. The number of users is constant. I think you can see that the graph. The number of users is
stays at a constant.